Conceptual energy performance in Formit 360 and Insight 360. Okay, let's go into Formit. There's our site model that we're familiar with. We've got all the buildings on it and we have a terrain. And what we're going to look at here is starting to model some proposed building forms, building heights, floor-to-floor heights, but with an emphasis on quick conceptual modeling and simulation. So let's say at this point we don't want to have to design a detailed building, and we don't want to spend all day, for example, modeling a full building, but we want to try out on site some potential sizes, some shapes, get an idea about how they perform. And then when we start to look at those buildings that we've modeled, we want to start a discussion about the kind of performance of the envelope, the performance of the windows, what renewables we could put in place, what systems for control we could put in place, and use that to start to understand what kind of energy performance levels we could possibly achieve. And the emphasis here is on an intuitive interface, and I think an interface that potentially in practice, in a practice environment, you could actually use with your clients and let them engage with the process. Okay, first thing we need to do is model a proposed building. So I've already created a layer and I've called it option A over here, which just will keep things tidy. And let's go ahead and model a proposed building. I'm just going to very quickly create something there. And let's, for now, let's make that 30 meters, let's say. Okay. Double click on that, G to group it. And I've just, sorry, at the moment, I've just put that, I've modeled it sloping. Well, we can leave that. It doesn't matter. You can model quite complex shapes if you want. So we'll actually leave that as a sloping building. Let's just situate it roughly on site there. Okay, there's our building. Let's just quickly go into that, edit it a little bit. Let's put a sort of raised section on here. That line didn't work. Let's just try that again. Did that work? Yes. So we'll just bring that little part up there. So I've made a building. I mean, obviously I'm doing that very, very quickly. You could take a little bit more care about how you did that. And that building is grouped. And if I just click on that building, go into properties up here, and let's put that into option A. Okay, good. So we've got that building modeled, and we can switch it on and off. So if we wanted an option B, we could switch it off and add an option B. Now, at the minute, Formit doesn't know that this building is the building that we are proposing compared to this building, which is the Arts Tower. So we need to distinguish between what's the sort of surrounding context building and what the building is that we want to actually simulate. That's pretty easy. We need to create some levels. So go over to the right here to levels. Click on the plus and we create a level. By default that is started at 0 meters above sea level. Now we happen to know that our Arts Tower forecourt is at around 110 meters, more or less, so we've changed that. If we start clicking on the add button, like that, we can just start to add levels, or there is the add multiple levels, which you can also use to add a number of levels with a distance between levels. So let's add a few of those. Okay, so we've got 10 levels there. That will do us for now. Now, to apply those levels to our proposed building, select your building, go into Properties, and click on Use Levels. Those levels you can see are now applied to your building, and they're visible as these blue lines. Now, you can selectively activate or deactivate any of those levels. So I'm just going to go and selectively remove a few there. Let's say we've got 2 floors here which are double height, and then a few floors here which are single height. Let's add one more level. Okay, if we go back into our building, that top level that we've just created, it's not really big enough, so let's get rid of that. Okay, now what you can see, we start to get, very useful, we get a floor by floor area here, and we also get a total area, floor area for the building. So that's already very useful in terms of making sure that the building you're proposing is about the right size. And if I just demonstrate, if we go into that building and just slightly modify it, let's make it a bit narrower there. Select it again, and our floor areas have all updated as you would expect. Okay, so at that point, I'll just hit save. But we're actually ready now to start doing some energy simulation. And the process in Formit, you simply go up to this button that says 19.1, which is the energy analysis button, and you would click on Generate Insight. Now, I'm not going to do it because I've already generated an insight for a very slightly different building. But when you generate the insight, it does take anything from maybe 5 minutes through to a few hours to simulate. The thing to remember is that simulation is conducted on the Autodesk servers. It's not done on your hard drive, on your laptop, which is great because it means your computer's then freed up. Once you click on that, the other buttons cancel, become active, and when the energy simulation is ready, the View Insight would become active. Insight is the term that Autodesk are using for these kind of energy analysis profiles of your building. So when it's ready, you can either click on the View Insight here, or if you simply go into your web browser and go to insight360.autodesk.com. If you Google Insight 360, you get there. Once you're there, log in. I'm already logged in. If I wasn't logged in, I would have the option to do so here. Click on your insights, and you're taken to a web platform that shows you all the different insights you've already done. So let's have a look in here. Okay, so you can see here I've got 3 different insights that I've already conducted, and we'll come back to this page in a little while, but for now let's just click on the one that we've been looking at, and then we do have to wait a little bit just while the website loads up. Okay, while that's loading, just to reiterate, we're talking here about rapid concept energy analysis. We're not talking about a detailed building with all the rooms and all the windows, shading devices, doors, user profiles. We're not talking about that. We'll cover that later on in this module. But for now, we want to quickly look at the size and shape of buildings and get a feel for how they will perform. Okay, the image is just generating here at the top, so we're just going to wait for that. But while it does, let's have a look around. We've got a location map here, just reminding us where we are, which is good. And top left, really important, we've got our energy use intensity. So that is the amount of energy, kilowatt hours per square meter per year for the building. So how much energy per square meter does that building use for the full year? Okay. You can click on that. I'm not going to do it, and it will change it to a cost in US dollars. But for now, we're more interested in the energy. And then we've got this little thumbnail which gets generated. And you can move around that, you can orbit it. To be honest, I don't really find that much purpose in doing that. The useful thing, which you can see quite clearly here, is that we can check that we are simulating the right building. So quite clearly here, just zoom in a bit there, the building which is coloured is our proposed building. Everything else is yellow, which is our site. Now, as I said, this the building we're simulating is one I did yesterday, so it's not got that funny shape that I just modelled a few minutes ago, but it doesn't matter, same principle. Okay, you've got various tools here for panning around. You can use that if you want. You can make it full screen here. You've got various different sort of display properties, but I'm not going to play around with that. It really, the only purpose there is to generate an image, which, you know, would be useful if you were maybe showing it to a client, but probably for us on this module, because we'll be generating more sort of sophisticated renderings, you probably won't use it that much, but it is there. Okay, you have to take screenshots if you want. It's not aimed at producing a kind of PDF report. We will cover that later through Revit, but really it's meant to be a sort of live snapshot, so you would just take screenshots as you go along. Right, let's scroll down a bit. Now what you can see, top left, is our current performance of our building. We're currently at 203 kilowatt hours per square meter per year. And here's a couple of benchmarks. If we're to meet the ASHRAE 90.1 standard, we need to achieve 382. So we're well below that. But if we want to achieve the Architecture 2030 standard, which is 72 kilowatt hours per square meter per annum per year, we need to be considerably lower. There's a separate video which looks at energy benchmarks, and what I've shown in there as well is things like Passive House, energy use intensity is 120, standard kind of SIBC benchmarks for example, an office is around about 180 for reasonable energy performance. So that's a sort of a guide. Okay, in the middle we've got a model history. Now I've already been amending the performance of this building, which is why I've got all these different performances where I've been trying lots of things out. You can, using this slider, you can limit what you want to see. So I'm just going to limit that to the last couple of options there. Okay, and then the way the Insight works, for each of these performance criteria of the building, you can modify them here and now. So let me, for example, let's look at this one. Window to wall ratio, western walls. click on that sort of spinny arrow and you get a graph, and click on the graph again and it takes you into another window where you can start to actually edit the performance. So at the top we've got our energy indicator. So this is where we are at now, 203. And at the bottom we've got a graph showing different possible window to wall ratios ranging from 95% glazed all the way down to 0% glazed. So if you imagine a building, you could go from a building that's virtually all glass to a building that's no glass on this particular western facing facade. And we can control this using these sliders. And what the sliders do is they let us select a range. So let's say, for example, we know for definite that all of those western walls will be 30%. Then we narrow that band down just to the 30%. And our energy use intensity up here will change accordingly. So let's move that to a different range. Let's move that right down to the 0%. And we've made a considerable energy saving here. Now the graph at the bottom as well, the horizontal lines show you the impact on the EUI these options will have. So for example, the 0% we're in now, down at the bottom, if we hover over it, minus 80 kilowatt hours per square metre per year. And that's reflected in the graph. If we went from that all the way up to 95%, and let's do that, then we've not only lost our minus 80 reduction, but we've added 95. So if we do that again, look now, we're at 267 kilowatt hours per square metre per year for 95 fully glazed. If we slide that all the way down to 0 glazed, we drop down to 130. So immediately you see the kind of impact that these decisions will have. Now, on the western wall of our building, we certainly don't want 0 glazing because that's facing the courtyard. So I'm going to put that up quite high at 50. Now, if you either have a range of glazing sizes, let's say you had a building with a number of walls, or you're maybe just not sure, you can expand to cover a wide range, and the insight will simply take the mean, the middle value. Okay, so let's say we're happy with that for now. Click on the cross. And if I go back up to the top, we've now got, in our history here, we can see the effect that that change has just had. So here's our new performance with a mean EUI of 201, whereas the one before had a mean EUI of 202. Right, let's make a significant change. Let's go to our east-facing wall. Here we are. Now that wall, I've already done that. I've knocked that down to 0% glaze because the way the building is designed, we don't need any glass on that. And really this is the way it works. You go through and you can make these changes to improve the performance of the building. So let's have a look at infiltration. Now again, I've set this quite a low level, but let's say that you maybe couldn't achieve that, and you're having more air changes per hour. That will make a significant increase. What you can do when you go through these graphs, let's have a look at daylighting controls. The graph gives you an idea about how significant the change will be. So if we look here, across all of these daylight controls, it would suggest not a huge saving in energy, but still worth having if you're trying to get down to very low energy levels. But you could imagine discussing this option with a client, and the client may say, well, I don't really want to pay for expensive daylighting controls if they're only going to save me a small amount of energy, and they may ask you to look for the more significant savings. So let's have a look. Let's have a look at the heating ventilation system, and what you can see here is actually there's quite a range of performance depending on the type of system you use. So for example, if we went to a high efficiency system, we make a significant saving there. So we've dropped down to 168. So let's keep that for now. Bearing in mind that's kind of more in the realm of the building services engineer. It's not really what architects would always get involved with, but clearly it shows here that there's a significant impact on the performance by having high efficiency heating and ventilation systems. Okay, we've got things about photovoltaics. Let's change that. So at the minute we've got 60% surface coverage. Let's go up to 75%. Didn't make a big change, but a little change. What else could we look at? I mean, in your own time, you can obviously look at this in detail. Things like your glass performance. Have you got high performance glazing? Yeah, I've already been in here and selected high performance. Southern windows. There's a saving to be had if we can have a bit less glass on the south facade. And what about shading that? We could improve the performance a little bit by having some very deep shades. So it's only a 1 kilowatt hour difference, but it might be worth having if you felt the design could cope with that. So if we look at our history, we are getting this building better and better. So we're down now at 163. So that's getting pretty good. What other things could we look at? I mean, you go through this carefully. The performance of your wall. Have you got high levels of insulation? Again, you can make a saving on that. Okay. Plug load efficiency. Let's drop that down. Okay, so I think I'm going to stop there because you can do this in your own time, and I do encourage you to experiment. But that's the principle here, that we make these changes very, very rapidly, and we can see how we can optimize the building without changing its shape. Now, when you change the window size, that is reflected in your visualization here. But the thing is, we're not really all that concerned about that at the moment, because that's the level of detail design that you would look at later. But what you could take away from this is when you move into a more detailed building, is the kind of window to wall ratios and the shading that you need to aim for. Now, as you move into a more detailed design, of course, you then want to check that against daylight levels. So it's it's not as simple as simply not having any windows. I often have to remind students that if you were to design an optimum performance building, it would not have any windows, but nobody would want to use it, would they? Okay, right. Now I'm going to go back to my Insight homepage. Very briefly, we'll talk about scenarios. What a scenario is once you've gone through and you've made a number of selections for the building performance, you can save that as a kind of selection set, which is called a scenario. So let's say, for example, you'd chosen a whole range of high performance insulation, high performance windows, shading. You might call that a name, save that as a scenario. That's just, there we are. So when we go back to our home page, what you can do is then apply that scenario to all of your projects here. So for example, I've had a one that I created the other day called medium PV. And if I apply that, it applies it to all of my projects. Just takes a second. And you can see now how, let's say you had a number of different building options here. How would they perform using those settings? And you get this, this display here. Okay. Now, there are a few presets. Sorry, that's my phone going. Sorry about that. There are a few presets here which are useful. So, for example, we can select the Architecture 2030 scenario, and that will apply that to all of our designs. And quite interesting, because what that then shows is that if we applied all of those settings, we could feasibly get our building down to 73, which is below Passive House. If we now click on that, that design option, it will retain those scenario settings, and we could go down and have a look. Just, it will take a few minutes to load up, but we could then scroll down and have a look at what settings we would need to achieve that. So just give it a minute. Now, as I say, those settings may not be achievable. So for example, it might demand the most expensive windows. It might demand, let's say, very, very deep shading. It might demand quite small areas of glazing, which may not be at all compatible with what the client needs for this building. So, for example, in your scenario building, one of the ground floor rooms is a cafe. Now, a cafe is not going to be a nice, pleasant space, and it's not going to sell much coffee if it's not got good windows. You know, no one's going to want to sit in a cafe which hasn't got good views and good daylight. So, you know, you can't always just choose the lowest energy option. But we've got that, that's done now. If we scroll down, we can look at some of the settings that have been used. Sort of, so we can see clearly very deep shading has been used. We've got about 40% window to wall ratio. We've got the best windows, the best performance of the construction. The air infiltration could actually go lower. It's not the best performance, but it's quite a low performance. Daylight controls. We've got occupancy, so in other words, we've got movement sensors on the glaze, on the lighting, but we've not got daylighting sensors. So you could actually slide that and make it an improvement. Okay, and we've got, what have we got? Photovoltaics, we've got a whole range. Photovoltaics, so again, you could improve that by having more. Okay, and that's the principle of how this works. To save your scenario, your own scenario, you would click on this button here at the top. Okay, so I'm going to stop there. The next stage here would be probably to try a different shape and size building, a different location on the site, and then bring that in and apply your scenarios and see how that performs. And that can be very revealing to start to understand that, let's say, retaining the same kind of performance of the construction of the envelope, does different positions and different orientation of the building make a significant difference? at this sort of conceptual level stage. And then the stage following that, which we'll look at later on in the course, is where we then start to analyze the performance of a fully detailed building with fully detailed windows, all the elements designed. Okay, I'll stop now and encourage you just to have a go with this and see what you think.